Okay, so first things first, recognizing when you have a zero of a polynomial, figuring it out on your own. It is a very simple idea. All these words might mean nothing to you. It says, given a polynomial, p of x, if p of a equals 0, then a is a 0 or a root. That's saying if you take whatever number I give you, your a, any number I give you, and you plug it into the equation, and your answer is 0, then you can say it's an x-intercept. Simple as that. The other part of that is saying if it's a real number and it's a 0, then you write it out as x minus a. So here's what we're talking about. For the polynomial, this long guy, find if the following are zeros. All we got to do is take the number I give you, 1. Let's plug it in. Let's start there. 1 cubed minus 2 times 1 squared minus 5 times 1 plus 6. 1 minus 2 minus 5 plus 6. Negative 6 plus 6, I get 0. 1 minus 2 is negative 1, minus 5 is negative 6, plus 6 got me 0. So what that means is 1 is a 0, meaning an x-intercept. So you would have a graph of this, you would see an x-intercept at 1. That's all that means, because we got the answer of 0. That also means that x minus that value, 1, is a factor. So it means two things. So like you guys are very lucky. You don't actually need to know how to factor these anymore. In pre-calc, I used to teach you this. AP does not require you to know. But the idea is that you would take x minus 1, use your long division, and keep factoring from there. Yeah, the long division you guys learned last year. I think we do long division in here. I just don't know when. Because they took it away from, you learn long division to learn how to factor this, which now you don't really need to anymore. Or some of your teachers taught you synthetic division. Yeah, synthetic. So what you would see is if you do 1 and use it as synthetic division, you'll get a 0 at the end. So it's meaning there's no remainder. That's what that means. All right. Let's check if 2 is a factor, or a 0, I should say. Plug it in. 8 minus 4 times 2 is 8, minus 10 plus 6. When I did that, I got negative 4. That means 2 is not a 0. 2 is not an x-intercept. 2 is not a 0. Very easy.
Plugging it in.
Yeah. And that just shows you that it is an x-intercept if it gets 0. Very easy start. That's called factor theorem. Not like that name matters to you, but that's what that's called, what we just did. Factor theorem. And so also follow up with that, since 2 is not a 0, that would mean x minus 2 is not a factor. So if you did synthetic division or long division, whatever you learned last year, which again, I don't think we have to do right now, not in this chapter at least, you would see you would get not a 0 at the end. You would get a remainder at the end. In this case, that tells you the remainder, negative 4, but no. All right. q of x is a polynomial of degree 6. If q of -1 equals 0, meaning if you take -1 and plug it into whatever equation they gave you, which they didn't give you one, you get a 0, meaning it was an x-intercept. Then it can be expressed as x plus 1 times the rest of the polynomial. What is the degree of p of x? So let's think about it. We started at a degree of 6. Then they already told us one of your zeros is -1. Now, with that exponent of 6, what does that tell us? The possible amount of, you remember, like the highest amount of something. What'd you say? Not coefficient, your x-intercepts. 6 tells you the amount of x-intercepts you could possibly have, including imaginary numbers. So if you already have one of your x-intercepts, how many more do you have left? 5. That's your degree. You already have one of your answers. They're wondering what's the degree of the rest of it. The rest of it's 5. So you started at degree of 6. They tell us your polynomial q of x can be explained as x plus 1 times the rest of the polynomial. So they already told us one of our factors. But we should have 5 more factors because of this. It started at 6. You already have one of them. So you should have up to 5 more factors, 5 more exponents. That's what that means. It's weird. Again, new concept. So same idea in example 3. They tell you q of x has a degree of 7. Then they give you 2 x-intercepts this time. So what can the rest of the polynomial be? Not 4, 5. Started at 7. They gave you 2 of those answers. So the rest of the polynomial, 7 minus 2 is 5. All right. So then just a little review in the next part of factoring. What we're going to be doing in the second on the next page is reviewing, do you guys remember last year your touch and the cross with the exponents? Do you remember that? Touching and crossing on a graph. You'll see. On the next page, it'll ring a bell. Yes, we're going to be doing all of that leading up to it. So just for time, I'm going to jump to B. Okay. A was just your star method, straightforward. That would be what you do. But in B, before we jump to star method, there's something we have to do first in B. Factor out x, GCS. They both have an x. They all have an x. We're going to take that out. When I take out that x, I have x squared minus 2x minus 8. That's what happened. You see that? Now we can go into our star method or box method. This is star method. A times C, so 1 times -8, -2 on bottom, x and x. What are my sides? -4, -4 and 2. Good. So yes, what you're saying, x plus, yeah. Yes, even 4, yeah. You didn't have to use U. That was smart. I didn't even think of that as an option. No, you check for GCF first in this. Good question. So here's what we write. This x at the beginning doesn't disappear. X minus 4, x plus 2. Then we find our x-intercepts. There's one more. 0. That x in front is 0. Okay. These are my x-intercepts. You get that from equaling it all to 0. Great question. If it said like 2x, let's say, so if it said 2x times all this, all that means is that it's still 0. It's still 0 because you're setting 2x or x or whatever it is to equal 0. You're still solving for it, and 0's on top when you solve that because it means it's 0. Good question. Good memory. All right. Now, why are we doing this? Let's find out. Multiplicity. This is going to come into the crossing and the touching. If a linear factor x minus some number is repeated, then it'll tell you whether it's going to cross or touch on that graph. So it says state all the zeros of this equation, then the multiplicities, the exponents. Multiplicity means exponent attached. So I'm going to write down the side, multiplicity slash exponent. All right. So you guys will be given a already factored out for you question, okay? Let's find your zeros, your x-intercepts. So I'm going to set x plus 1, I'm going to equal that to 0, and this to 0, and this to 0. So when I do x plus 1 equals to 0, and you solve, what do you get? -1. So my first x-intercept is -1. Now I'm going to find the multiplicity, the exponent attached to this. What is it? That's the exponent attached, the 2. So I'll write that. Multiplicity equals 2. Good. Even. So 2, is that an even or odd number? Even. The fact that it's even means it's going to touch the x-axis, which I'll write that here. Touch. So that's what I was talking about, if we remember this touching and crossing.
We have to put for that be there?
What do you mean? You'll have to know 2 is even. I mean, you'll have to know that it touches. Yeah, I wouldn't tell you that.
We would have to write it.
Yes, you don't have to write like all this out. Just tell me like, you'll see. I think I have an example of what it would look like. All right, so then what's the next x-intercept we see? 3. What's that multiplicity? 3. The exponent attached to it, 3. So multiplicity, oh, and you said odd. Yes. I thought you said 5, and I was like, what? So that's odd. Odd means it'll cross your x-axis. We'll see in a second in the picture below. And then the last one would be -4. And the invisible exponent or multiplicity is 1. So your multiplicity is 1, which is odd. So we'll see it cross. Now, just to your question, you don't have to write all of this down. You'll see how I think in a second, you'll see how it goes. Moral of the story. If it has an odd multiplicity, then we'll call it a cross. And I'll show you in the picture what that means. If it has an even, then it touches. So here's what that means in this graph. So we got they graphed the polynomial above. They graphed this down here. So we said, let's go read it left to right. At -4, we said it crossed because of the exponent attached to it, the odd. Here's what it means. Let's take a look at -4. Right here. That's called a cross. It's crossing over the x-axis. That's what we mean by crossing over. Versus at -1, it does a touch. So it hits up -1, but it never actually crosses above it. It stayed below. So some teachers call it a bounce. It bounces off it. The x-axis is like your wall. So it touches the wall, then goes bounce below. That's what we mean by touch. And then at +3, we said it crossed. So right here at 3, it looks like it's touching it, but eventually does go through the x-axis. It started below the x-axis, and then at 3, it went above. So that's what we're talking about, x-axis, touching and crossing. All right. Now, before I do this, let's kind of explain how I want it written out. Now, this is a little different than the question, but here's how, if I give you this equation, and I say, state your x-intercepts and what they do, cross or touch. So you would tell me in A, for instance, you would tell me x equals -4. You do not need to say multiplicity 2. Just tell me, what does a 2 tell me to do? Touch or cross? Touch. That's how I would want it. -4 is touch it. You see what I mean? You could write out the number if you'd like to help yourself. 2 is even, so it touches. Not today, but yes, it is in the next lesson. So then at +2 it crosses, and at -1 it also crosses. So -1 it crosses, and then at 2 it crosses. So with that knowledge, A, B, C, and D. So let's see which one it matches with the graph, A, B, C, or D. You're trying to match it. Even touches, yes. Let's see. So at -4 it touches, at 2 it touches. It is B. Who said that? Yeah, good. So let's take a look. If we kept doing this list, x equals -4, it touches. I'll put a T for touch. X equals -1, exponent is 1, so it crosses. X equals 2, it touches. This is the exponent. So if we look at A tells me it just touches at -4, which it does in this graph. But then if you take a look at 2, it also touches. That's why we know it's not A. A, we said at 2, it crosses. B is the answer because at -4, it touches. Then at -1, it crosses the x-axis, and then it gets back to 2, it bounces off it, touches it. It never goes below. That's what cross would look like if it went below the x-axis. So the answer is B there. Okay.